All right, welcome to this next video. In this video, we'll be dealing with integration of trig functions using identities. And the most important thing that I want you to remember is that with these identities, if you are able to quickly identify what identity you need to use, the identities are given to you in the formula sheet in the further studies module. And all you have to do is to get to manipulate the identities that you have in order to solve your question. And if you are able to pick up these identities from the get-go, it makes solving them so much easier if you can easily manipulate the identities. So let us start with the first one. So here I've got sine 3x, cos 3x. Sine, cos, I'm sure you all remember that this is a double angle. Okay, and if you look on the right on the formula sheet, the double angle is that. You can see that sine of A, cos of A, it is the same angle. All you have to do is divide by 2, where you have sine of 2A over 2 giving you the sine A and cos A. So we can come and do that substitution here. So what this will mean, this will be, remember, we just have to double the angle. So this becomes 6x over 2, and therefore that gives you your dx. Once you're at this particular stage, this is not a very complex integral to solve. The 2 in the denominator there gives you a constant, and all that you are integrating is the sine of x dx. And I think we are all confident with this by now, using information from the previous video, that the integral of sine will just simply be minus cos of 6x, and then we will have to divide by the 6 plus the constant of integration, and all that we do in the next step is merely simplify this. So our solution becomes minus 1 over 12 the cos of 6x plus c. And this is one of the first examples that we use our identities in order to solve complex looking like integrals involving trigonometry. So let's dive deep and do some more questions. So I've done B on the other side. Don't know why, but let's see how we would go this way. So let us see if we were to solve sine squared of x. So sine squared of x, I think we can all identify that sine squared of x is a square and it's an identity. But in our formula sheet, we don't have the integral of sine squared, and using u substitution here is not going to help. So what we do, we come and pick up this identity with the cos of 2a, because that's where sine squared is. We can't pick up this one because we still have a cos squared there, and even if we use u substitution, it does not work out. So therefore, what we will do, we'll try and manipulate this identity, saying that the cos of 2a equals to 1 minus 2 sine squared of a. So we'll manipulate this so that we have sine squared. So what we'll do, we'll take the 1 to the other side and then divide by negative 2 on both sides. So if we do that, let's just do the step by step. Minus 1 equals to negative 2 sine squared of a. And then if we do that, we divide everything by negative. This gives us just 1 over 2, and this gives us minus cos of 2a over 2, giving us sine squared a on the other side. So us being able to manipulate that identity will help us solve this one. So what this means is that wherever we find sine squared x, we can now simply replace it with 1 over 2 the cos of 2a over 2, well, 2x in our case, 2x, and then we can go dx. And this is simply the same as taking the integral of each of these individual functions as they are by themselves. So we can work out that the integral of a half will just simply be a half of x minus, so you can have the 2 on the outside, and therefore all that we're doing is taking the integral of cos of 2x. So we know that the integral of cos is sine, so this gives us sine of 2x, and then we divide by the coefficient of x, which is 1 over 2, plus c. And what we then do in our next line is just simplify this integral to give us minus a half x, and then minus 1 over 4, because it's 2 times 2, sine of 2x plus our constant for integration. So our ability to know how to use to know how to manipulate these identities does help us in solving these particular questions. So therefore, what I would then like to take us to is to be able to do the next question. So let us look at this. We've got sine of 3x, cos of 3x. But if we look into our formula sheet, we can clearly see that in this expression here, we've got sine A cos B, which is exactly what we're looking like. And this is a compound angle that simplifies into what that right-hand side is. So when you've got an integral like this again, all that you have to do is make sure that you calm down. This is just the integral of half. And then in that, you are integrating the sine of, so this first angle will be A and this one will be B. So in brackets, you can go 3x plus x plus the sine of 3x minus x, and put that to the dx. So we're able to identify this because it is given in our formula sheet, and you'll have all sorts of examples. You can either have sine A, sine B, cos A, cos B. You just need to manipulate depending on the question that we have. It's just that the question we have now has to do with sine A, cos B. So let us finish this up. So we know from here the half is merely a constant there, and we have to integrate this. So this will be the sine of 4x plus the sine of 2x dx. And because the half is on the outside, we can easily come and integrate this. The sine of 4x simply just becomes minus cos of 4x divided by 4, plus or minus again. This is the sine of 2x, which is sine of 2x divided by 2 plus our constant for integration. And all that we do is simply multiply the half in there. So therefore, our final answer becomes 1 over 8 cos of 4x minus 1 over 4 the cos of 2x. Now, it looks like I had forgotten the solution there, and hopefully I fixed it. So I hope this video gives you a good understanding on how to use identities, use your formula sheet in order to simplify integration that involves trigonometric functions and their identities in order to be able to solve them. I hope this has made a lot of sense. I hope you practice with more questions, and I will see you in the next video.